Hello everybody, this is Petri. So since last time I got some feedback actually from my last video. Alan here says that it would be awesome to get some sort of support for assertions in the code. And actually that's what I have been doing lately. Let's look at this code for instance. It's updating our teleporters in the game. So it's looping over those teleporters. And let's assume that we are optimizing this code and we would like to get rid of this load, which loads the current map index into X register. We are loading that X register here already, so maybe it would be fine to actually remove this load in here. So let's try that. We can actually check it by adding this line here. Like we have to assert that X equals whatever is in memory at this address. So this is now an arbitrary Lua code that gets executed when the emulator gets into this address in memory. So now if this line is not needed, this assertion should never fail. Okay, let's check it out. Boom! We get assertion failure here. Okay, so that means that register X doesn't contain the current map index at this point. So okay, maybe we can't remove this instruction here. Well, that's nice. So the nice thing about this system is that these are not actually not at all contained in the compiled binary. So how this works is that the VIC emulator will actually load up this source code and parse all these lines that start with these double semicolons. So this will not affect the compiled program at all, which is very nice because we can leave all kinds of assertions in the code. So what else could we do with this system? So for instance, we can evaluate any expression, for instance like that, and the value of this expression will go on this line. So this line will be actually replaced by the value of this expression. So let's check it out. 6. So that's the value of this expression. But we can do more. Let's print the current position of the party in here. And since our party is actually packed, or the position is packed into 1 byte with 4 bits each for X and Y, we can unpack those values here. So let's load the party pos from memory. And this is the packed value. So the X value is actually the lower nibble. So we can extract that. And the upper nibble is the Y coordinate. So now you can see party pos is 7 and 14. So X is 7, Y is 14. And this actually updates in real time. So we can move around in the level and this gets updated. So that's pretty handy. We also have support for profiling here. So we can insert arbitrary profiling blocks like this. And we have to mark the end of the block where we want to stop profiling. Like this. Now we can see how many cycles this block of code actually takes. And we can still move around in the level, so it's all real time. It's jumping a bit because there's some teleporter somewhere in this level that is actually animating. So this cycle count is changing in some frames. So we can go pretty crazy with this system actually. So for instance, just an example, we can do this. Sorry. So we can play sounds. This is now the move party routine. So now let's compile. When we move, we can hear the sound. Okay, that's just one sample we are playing right now. But how about if we do this? This is a random value from 1 to 5 here. And something is, I'm missing parentheses there. Now it's randomizing the sound to play. So this could come in handy actually when I'm doing the PC port of this game. So I can like have better sound effects in the PC version, which is basically the same game, but I just plan to embed some additional sounds here. So I think that's all for today. Thanks for watching. I hope you liked the video. Give me some comments or feedback if you want to see more of these. See you later.